Okay, so I want to look now at some examples of this trig. One example I want to do is going to look like this. This is a right angle. I'll pretend it looks like a right angle at least. This angle here is, let's go 68 degrees. Let's put this down here at 300 feet. And over here, we'll put this at 220 feet. I want you to find this angle right here. We'll call it angle A. How would we go about doing this? Now remember, we need to find right angles. We have a right angle here, but if we cut it across there, then we don't know. We have to find right angles where we know at least one other angle in the triangle, right? Or two sides of the triangle, one of the two. I mean, I suppose I could cut this across here, and I would know two sides. I'm going to here, by the way. And I would know two sides of that triangle. But does that help us at all? Not really. You know what? I need to give you one more piece of information here. I'm going to give you this. I'm going to tell you that this up here is, let's go 180 feet. So what I can do is, in the process of making triangles, it helps if I make rectangles with what's left over. So whenever I have a shape like this, if I can cut off the corners to make right triangles and leave behind a rectangle, that is very, very helpful. Because once I know one side of a rectangle, I know the other side of a rectangle, right? Same with the up and down, the top and bottom. So I know that this side of this rectangle is how big? 180 feet. So that means this piece here is 180 feet, which means this piece here is 40 feet, 200 minus 180. So I've already got a side to that right triangle too. Now I look at my right triangles. If I look at this one up here, I have the 40 feet. I have the right angle. I have one side. I either need to know another side or one of the other angles. Do I know any of those? No, I don't. I don't know anything else. So I can't find anything else in that one. If I knew either this side or this angle, I could do it. I could find A. So let's go down to here. Down here, I have the right angle. Do I have two other pieces? Yes, I have this side and I have this angle. Which piece would it be beneficial for me to find? Well, if I find the hypotenuse, does it help me with anything on this triangle? Not really. If I find this side, though, does that help me find anything on this triangle? Yeah, because it'll let me find this by subtracting from the 300, won't it? Which is the same as that. So let's call that, we'll call it X, what the heck, right? This is the angle. I'm using the 68-degree angle. What side of the triangle do I know? 180 feet. What side is that? That's the opposite. That's the only side I know, so now I look for what side am I trying to find? The X, and that's the adjacent. What trig function is that? Tangent. Tangent to theta is opposite over adjacent. What am I going to fill in here? Tangent, I put in 68 degrees, equals 2.08 over x. Now, since I'm looking for a side, what do? Put it over 1 and cross multiply and divide. 1 times 180 is 180 divided by the tangent is 68. 72.72. So what does that tell me about this length here? (300 minus 72.72), which means it is 227.28 feet, correct? So that means this is 227.28 feet. Now what? Finding this side, is that going to help us any? We just need to find A, right? So we have two sides, right? According to that angle, what side is the 227? Opposite. What side is the 40? Adjacent. That means we're working with a tangent. Definition of tangent. Tangent of theta is opposite over adjacent. Do we know the angle? No, that's angle A that we're looking for. Do we know the opposite? 227.28 feet. Do we know the adjacent? Yes, 40 feet. Since we are looking for an angle, what do we do? Inverse trig. Very good. So A is going to be the inverse tangent of 227.28 divided by 40. 80.02. That's my angle A. All done. What do you think? Wondrifical? I'm George Bush now. That is wonderificus. This is a half circle. It has a radius of 20 feet. This is 12 feet out here. It is a go ahead. 312 slope. This is a tangent here where it hits the circle. So I'm telling you this tangent. Otherwise, I could not assume that. Now, are there right angles here, I should say? There's one right here. And where can I create another one? Radius to tangent. There's a right angle there. I need to know either this angle or both. Can't cut them in half because I don't know either angle, right? I don't know exactly where it would get cut in half. It wouldn't necessarily cut the angles in half. I can find this angle up here though. If I cut it like this, making this a right angle, right? This wall hopefully is vertical, this is horizontal. So they have to be perpendicular to each other, right angle to each other. I can find this angle right here. How? My 312 slope, yeah. That 312 slope can be thought of as a triangle. A rise of 3, a run of 12. This angle here is this angle right here. That angle, 3 would be the opposite, 12 would be the adjacent, right? So that angle is the inverse tangent of 3 over 12. That is that calculation right there, by the way. Oops, I did not mean to scribble it out. I have to highlight it. That calculation right there is extremely common in construction. When we're dealing with trusses or any of that stuff, the heel angle is the inverse tangent of the slope. So inverse tangent of 312 is 14.04. Now you might be thinking to yourself, wondering, how does that 1404 help us? Well, because now we know that this whole angle here is what? Where did that come from? I had this angle here is 14.04, and this angle is 90. And they do share a vertex and they share a side, so they're adjacent angles, so I can add them. Now, if that is 104.04, what I have here is a four-sided figure. And a four-sided figure has an angle sum of how much? 180 times n minus 2, where n is 4. So 4 minus 2 is 2. 180 times 2 is 360 degrees. So I have 360 minus 90 minus 90 minus 104.04 tells me that this angle here has to be 75.96 degrees. With me so far? Questions so far? Again, that's just 360 minus 90 minus 90 minus 104.04. By the way, I didn't really tell you what we're trying to find here yet, did I? I want to find that distance x all across there. Well, now that we have that angle, I can make a triangle here. If I drop this down vertically to make a right angle there with the horizontal, I have a right triangle here. Correct? So I'm going to pull that triangle out and work with it. I know this is my right angle, and I know this is 75.96 degrees. Do I know any of the sides of that triangle?
Yes.
Which one? I know that hypotenuse there is what? 20 feet. It's my radius of the circle. Let's find both of the other two sides. I'm going to label them A and B. If I am committing to the 75.96 degree angle, which is this one here, side A is which side? Adjacent. Side B would be the opposite. So to find A, let's do A first. A is the adjacent, and of course, 20 you said was the hypotenuse. Adjacent and hypotenuse are what trig function? Cosine. So I write down my trig function. Cosine theta is adjacent over hypotenuse. And then I fill in what I know. Do I know the angle? Yes. 75.96. Do I know the adjacent side? That is side A. No, I do not know it. Do I know the hypotenuse? 20 feet. I better know the hypotenuse because I can only miss one piece. So I'm looking for a side. I put it over 1 to make a proportion. And cross multiply and divide. Cosine of 75.96. Make sure I close the parentheses. Times 20 divided by 1. 4.852 feet. That's A. Now, of course, that is this dimension right here. Correct? Yes, it is. For B, B is the opposite side, opposite, and I'm going to still use the 20 because that's a given. I don't want to use the A because that's rounded off. I don't want to use a rounded answer to calculate another answer if I can avoid it. So I have opposite and hypotenuse, which is sine of theta is opposite over hypotenuse. So I write out its definition. Do I know the angle theta? Yeah, it's still 75.96 degrees. Do I know the opposite side? That is the B that I'm looking for. Do I know my hypotenuse? 20. So once again, I'm looking for a side, so I will do what? Perfect. I put it over 1 and I cross multiply and divide. Sine of 75.96. Close that parentheses, times 20 divided by 1. Gives us 19.403 feet. That is this distance right here. Where do I go from there? Well, I can make another right triangle off of this line here by cutting across here. There's a right triangle. You might be thinking, well, how does that help me? Because I can now find this side here of that right triangle. How can I do that? Because I've made a rectangle here. This is a rectangle, which means if this is 12, that's 12. You had it right there. You have to subtract 12. So this side is 7.403 feet. So I'm going to take that triangle out of here to work with. Here's my right angle. I know this side is 7.403 feet. And I know this angle here is 14.04 degrees. That's just going back to before I added it to the 90, right? Right here. The side that would be helpful is if I knew this side, because that would give me this length right here. That would tell me that distance to there, which is part of my x, right? That distance right there. So I want to find that side. Using the 1404. The side I know, the 7.403, is which side of this triangle? From this angle, the 7.403 is opposite. So I know the opposite. I am looking for the adjacent, which makes tangent. Tangent to theta is opposite over adjacent. Do I know my angle? Yes. 14.04 degrees. Do I know my opposite? 7.403 feet. Do I know the adjacent? Bless you. No, I don't. So I put that over 1, and I'm going to cross multiply and divide. 1 times 7.403 is 7.403 divided by the tangent of 14.04. 29.604. Correct? So 1 times 7.403 is 7.403 divided by the tangent of 1404. 29.604? Perfect. So this distance here is 29.604 feet. So I'm going to be able to add that to the 4.58. I'm still missing a piece though. What is it? I need this distance here, which is how much? 20 feet. So now I just got to add them up. So I'm going to take these here. I've got 20, 4.852, 29.604, which gives me 54.456 feet. What do you think? You got lost? The hard part on this is finding triangles. Because a lot of people will want to well, and most people, their first instinct this crap out of my way. Their first instinct is, oh, there's a right angle here, so I'm going to cut it across there. Problem is, I know the 12, but I do not know this distance here. I don't know either of these angles. I can't find them from anything. But once you realize that you can find it, and it's kind of a trick to realize that you can find this angle by cutting it like that and adding the 90 to the slope angle. And once you have that, you can find this angle. Once you got all four angles, then it opens up your options a little more. But then you're still, most people are still, now I've got all four angles, they still want to cut it here. But they don't know how it splits this angle or this angle. A lot of people draw lines and say, oh, it cuts the angles in half. Well, no, it doesn't. That problem varies drastically from this problem. Why does this vary so much? Different numbers, but I gave you a different thing here. I gave you this. I'm trying to find the height of the wall here instead of the distance across the bottom. So I can still put this in here and get a right triangle there, right? This, of course, is 28 feet, my radius. There's still a right angle there. I am still going to do this. This angle here is going to be found by doing what? You're absolutely correct. 412. Inverse tangent of 412. So it's the inverse tangent of the slope, remember? Opposite over adjacent, you're correct. 1843. So that means this angle, total angle, is 108.43. Because, of course, that was the right angle. Yep. Which makes this angle here. Yeah. Yeah, 360 minus 90 minus 90 minus 108.43. Now what? Well, now I do know that from here to here is how much? 28. You're still going to have to do this. What you're going to find is you're going to find this height here. You're going to find this height here. You have to find this distance and this distance. I'm going to give you guys about 5 minutes or so to work on that. See if you can come up with what you need to get X. Remember, the key to this is that X here is going to equal this distance here. So really, you're just finding this length from here to here, and that's X. So I'm going to pause. Okay, so I do need to find this length right here. What is it? This one. 8.852. Do you all concur? Yes. What is this length right here? 26.564. Do you all concur? Yes. So, if this is 8.852, that means this one is 44 minus 8.852. Otherwise known as 35.148, correct? Which means that this piece is 35.148. What's this one then? 11.713. Do you all concur? You don't have any choice? So that makes X how much? 14.851. So that is 14 feet. What do we do next to convert to feet, inches, and sixteenths? Minus 14. Then times 12 will give us 10 inches. Then what? And 16. 3/16. 14 foot, 10 and 3/16 inches. Guess what? Page 760 through like 764 in your book. It's exercise 35-3. Problems 1 through 15. Heavy duty odds. Just for fun. And yes, you will get a quiz to take home over the weekend. Hold back your cheers. Oh, this is really hard to take it back.